Okay, so now what we're going to do is we're going to talk about reactions involving radicals in a generic way. And we're going to review a little bit of what you should remember from Gen Chem, because it's a supplemental lecture anyway, we might as well cover it. Okay, so here we have two generic molecules, A bound to B, C bound to D, being converted into two more generic molecules, A bound to C and B bound to D. Okay, and what we want to do is we want to predict the energy of this reaction. Is it exothermic? Is it endothermic? Okay, so remember, whether something is exothermic or endothermic has nothing to do with how fast the reaction is. Okay, it has to do with the energy levels of where we started relative to the energy levels of where we end up. So starting materials to products. Okay, to do this, we analyze the bonds being broken. So in this case, the AB bond has to break and the CD bond has to break. Okay, this is going to be happening homolytically in this scenario. Okay, so the AB bond is going to break as shown here, as previously discussed, to give us an A radical and a B radical. Likewise, the CD bond is going to be homolytically cleaved to give us a C radical and a D radical. So remember, it takes energy to break a bond. All right, here there's a picture of somebody breaking a baseball bat. Okay, obviously it takes a lot of energy to break a baseball bat. Or, you know, you've probably all broken a twig at some point in your life, or a branch. Okay, you had to put a lot of work or a lot of energy into getting that to break. Okay, the same thing is true of chemical bonds. We have to spend energy to break that bond. Okay, this means that all bond breaking phenomena are endothermic and delta H is positive. Okay, we are putting energy into the system. Okay. The next thing we need to do is analyze the bonds that are being formed. So the AC bond and the BD bond. So this is how you would draw two radicals forming a bond. Okay, now we're still using the single-bladed arrows, but now they are pointing towards one another, indicating that they are going to join up to form a pair, an electron pair. In this case, it's a covalent bond. Okay, and so this shows how you would form an AC bond or a BD bond. Again, these are just generic examples. Okay, bond forming is always exothermic. Okay, we are always getting energy back out. Delta H is negative. Okay, and this is releasing energy. It's giving energy back. Okay, so endothermic, we are putting energy in. Exothermic, we are getting energy out. Okay, I like to use an analogy of thinking of energy as currency or money. Okay, so think of it as an investment. Okay, in order to do a reaction, you need to break bonds in order to form new bonds. All right, so it takes an investment to get it started. Okay, just like if you're starting a business. Okay, so we have to spend energy, or think of it as money. So we're spending money, we're making an energy investment into breaking our initial bonds. Okay, it's the only way to get this started. Okay, then we get a return on our investment. All right, we're forming the bonds that we want. Okay, so whereas we put money in before, right, we are getting the money back now. Okay, so in this analogy, we want our overall bottom line to have a negative number, right? The bigger the negative number means the more money that we're getting back from the system, okay? And that's what bond formation is always giving us energy back, and it's a negative delta H value for enthalpy. Okay, so how did our bottom line turn out? Did we profit or did we lose money? Okay, again, remember, in this case, profit would have a negative number because that's the energy that's coming out of the system. Okay, and the answer to this question, we can't use a generic system. We have to have a real system, and we have to use our bond dissociation energies or enthalpies. Okay, so remember, delta H is positive with our initial energy investment, and then delta H is negative when we get energy out to form these new bonds. Okay, so since breaking bonds costs us money, we have to put energy into the system, so a positive delta H. The enthalpy of breaking bonds is always going to be positive. And when the new bonds form, delta H is going to be negative for those bond values because we're going to be getting energy back out. Okay, so what we do for these situations is we go and find all the delta H values for the breaking bonds, and we subtract all the delta H values for the bonds that are forming. And this lets us predict the change in enthalpy for a reaction. Okay. So remember, this isn't delta G. We still haven't talked about entropy yet, but we're really not going to talk too much about entropy in this class. So hopefully you're comfortable with that from Gen Chem.